This is another functional group, so we're kind of continuing on in probably a four-part series of functional groups, but today we are looking at alcohols. And alcohols have the functional group that's called the hydroxy functional group. And just like we looked at halohydrocarbons, where we had stuff like chlorine, fluorine, bromine, iodine, they were just a single atom that was our functional group. Well, hydroxy, if you remember back to polyatomic ions, hydroxide, which was OH. So OH is a functional group. It's called the hydroxy group, and it is simply something that goes along our carbon chain. So if we were to draw CC, and then put an OH up here, and just leave everybody else H's. So just into each of these dashes we have H's. How we name this is we first look at how many carbons is our longest chain. It is 2, so we're going to start with F something. And what happens with this one, instead of calling it an ethane, this functional group has its own suffix. So we still have the F prefix, but alcohols have a hydroxy group, and their suffix is always -al. So this becomes F-anol. This particular alcohol is beer alcohol, wine alcohol, but ethanol is two C's with an OH. Another fairly common one that you may have heard of, is COH, and then just 3 H's. And how many long is this? It's just 1, so meth is our prefix. And because it has an OH group, we get the suffix -al. And notice on both of these, we don't have to use the number 1 here because we only have 1 carbon. And up here, it doesn't matter which way I start, it's always going to be on carbon number 1, so we don't have to use numbers yet. Another one that you are likely familiar with is this one. Alright, so we have 3 in a row, so this is going to be prop, because we have 3 carbons in a row. But this group, it affects our suffix, so this is propanol. But this OH could either be on our second carbon, or it could be on our first carbon. So this really is 2-propanol. Its common name is rubbing alcohol, so you likely have this at home in your medicine cabinet. But we can have alcohols that go to whatever, so we could have a bunch of C's, we might do something like that, have an OH here, and let's just for fun put a CH3 here, or just a C with 3 H's on it. So our longest chain is the middle one, so in this case what we have is, let's count that up, 1, 2, 3, 4, 5, 6, 7. And we have this group right here. So all of that we can call heptanol. But at the beginning of this, we need to say, where is our alcohol? I can just tell by looking at that I need to start on the right, so it's on my 3rd carbon. And then this would be placed on my 4th carbon. So I really have a 3-heptanol that has a methyl group attached, because this group right here just has 1 carbon long, and it has to be on carbon number 4. So this would be a 4-methyl 3-heptanol. But notice the anol, 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 anol means that we have a hydroxy group somewhere on our chain, and we denote that with the number. So that's alcohols. Again, drinking alcohol is ethanol. Methanol is moonshine. A little bit of this can make you go blind, and it's crazy if you can imagine. I've tried to stress this, especially first semester, how crazy small atoms are. To have 1 carbon different and 3 H's, but the H's are even smaller than the carbon. But to have something that small, and our bodies treat it differently. Our bodies are crazy how sensitive they are to the very smallest things. So methanol can make you go blind, methanol, too much of it you can go drunk, and then propanol you don't want to drink at all, and just 1 carbon different. How that affects our bodies is quite amazing.